Let's pick up with the third lesson in our section 3 on operations with real numbers. We're going to look at exponents and their inverses as well. So exponents is when we have a natural number as an exponent, it is just a shorthand for repeated multiplication. So recall that multiplication is a shorthand for repeated addition. We also have a shorthand for repeated multiplication. We call that exponents. Some key terms to note: factors. Factor is when we have two or more numbers multiplied together. Those are all called factors. A base, when we're referring to an exponential expression, is the number that is a repeated factor. So what's being multiplied over and over and over. And then an exponent tells us how many times to do that multiplication. So we can look at an example here, and we see that with this exponent, we have a base of 4 and an exponent of 3. So 4 is going to be a factor, or multiplied 3 times. Once, twice, 3 times. And so 4 times 4 times 4 gives us 64. And so we can do that regardless of how many times or what our exponent is. But there's a couple nuances we'll want to pay attention to. So to start, we have 3 to the second power, so our base is 3, and we multiply it 2 times. Here, our base is 1/2, and we multiply it 4 times to get 1/16. Now, C and D are very similar, but note the parentheses around D. What this is saying is that we have a base of 5 for the first expression, but we have a base of -5 for the second expression. And so it's going to change how our solution looks. 5 is our base, so 5 is our repeated factor. And then this negative says, okay, once you have that repeated factor, go ahead and make that solution negative. But in this case, -5 is our base, so we just take -5 and we multiply it by -5, which will give us a different solution. We can follow the same logic with G and F. However, it's going to be a slightly different result because instead of doing 2 multiplications, we're doing 3. And you'll see this pattern alternate based on whether you have an even number of multiplications or an odd number of multiplications. Our base here is still 5, so we'll have 5 times 5 times 5, and then we'll make that product negative, versus having a base of -5, -5, and -5. However, we still end up with -125 for both of these due to the fact that it is an odd number of multiplications. Now, just as subtraction is the opposite of addition, division is the opposite of multiplication, square roots are the opposite of squaring a number. So the opposite of squaring is taking a square root, denoted by the radical symbol. So if we look at the square of 4, we get 16. If we think about the inverse of that, the square root of 16 is 4. The problem is that 4 squared is not the only number that equals 16. -4 squared also equals 16. So we have to have a way of figuring out, well, do we want the 4 or do we want the -4 when we take the square root? That's where principal and negative roots come in. The principal root is the positive square root of a non-negative number. We have no sign up here. This implies positive. Versus the negative square root is the negative square root of a non-negative number, and it's denoted with this negative sign in front of the radical. And that's how we determine, do we want the 4 or do we want the -4? Now, you need to remember that the square root of a negative number is going to be not a real number. We talked about sets of numbers in the last lesson. And so if we take the square root of a negative number, it's not real. And if this number here is any even number, the tiny little number that shows up in this spot, if there's no number there or it's an even number, it will always be non-real as our solution. So we can go through and find each of our roots. We want to think about for 9, what is the square root of 9? Well, it's 3, because 3 squared equals 9. Because 3 squared equals 9. And then negative square root of 36 equals negative 6, because negative 6 squared equals 36. The square root of 0 is 0. The square root of 1 is 1. Those two are always going to be very consistent regardless of what the index is or what the exponent is, either one. The square root of 0 is 0. The square root of 1 is 1. The square root of 1/4, well, we want to think about what squared is 1/4. Well, that would be 1/2. 1/2 squared equals 1/4. And then last but not least, we have the square root of negative 36. This will be our not a real number, because no number squared equals negative 36. We can also do higher roots. We just have to include more multiplication as we think about it. So negative 2 to the third power equals negative 8. And since that is true, the cube root of negative 8 has to be negative 2. And we can see that represented here. And also note that negative 2 cubed is not the same as 2 cubed. Just like if we had our square roots, they were the same value. Here, they are not the same. Negative 2 cubed is negative 8, while 2 cubed is a positive 8. So we get two different values there. So we don't have to worry about the positive or the principal and the negative roots, because we don't have that when we have the odd exponent or the odd index. When we go up to the fourth power, then we go back to the same rule with squared, 2 to the fourth power is 16. Therefore, the fourth root of 16 is 2. So we can find the roots. The third root of 27 is 3, because 3 to the third power is 27. The fifth root of 1 is 1. Doesn't matter what the root is. If it's of 1, it'll be 1. This one wants the negative root. And so the negative fourth root of 81 is negative 3, because negative 3 to the fourth power equals 81. Here we have the fourth root of negative 81. This is also going to be not a real number, because that is even and this is negative. And then last but not least, we have the fifth root of negative 1. That is going to be negative 1, because negative 1 to the fifth power equals negative